Salesforce runs on a multi-tenant architecture. This means all the code and config we do within an org are stored on a shared server. This is one reason why Salesforce recommends bulkification. Collections come in handy when dealing with bulk data. There are three types of collections in Apex: list, set, and map. All three collections can act on the following data types: primitive collections, where you can use collections within collections; Apex defined; and user defined. The latter three will be part of another video, while collections with primitive data types is today's focus. If you haven't watched the video on what primitive data types are and how to declare them, please click on the top right corner of the video or check out the link in the description. Let's start with list. List is an ordered collection of elements that are distinguished by their indices. An index of a list starts with 0. A list may also contain duplicates. When we talk about list, imagine the following visual: square brackets to the start and the end with multiple values separated by comma. Constructing a list can be done three ways. Using the infinite values syntax, it means we can store as many values as we like. Infinite plus predefined value syntax and limited elements syntax. For syntax 1, we define the list as the collection type. Use angle brackets and place the data type within. Define a variable for it. Then for the assignment, we use the new keyword to create a new instance of the list. Finally, we call the built-in list class along with the data type and the parentheses at the end. For example, here's an empty list of string with the variable name student names. To add a value, we use the variable name followed by add method and pass in the value as the parameter. This is what our current visual looks like. Let's add one more student name to our list. Here's a similar example with a list of integer data type. In this scenario, we have added a duplicate value. However, the list does not care about the duplicates and our value persists within the list of elements. Furthermore, let's look at an example where we create a list of subject, an account. Here we have a new initialization of an account and pass in fields such as name with its value. Please note that the passed in parameter value to the add method must match the variable's data type. Let's take a look at the visual of how subjects get structured in a list. We have a list of accounts that contains curly brackets. Those brackets then hold all the fields and its values that has been defined. Let's look at another example to see what happens if we pass a different data type value to the add method. Here we have a list of string with a few values added to it. Next, we add a new value. However, instead of a string, we pass an integer. As a result, we get an error saying incorrect signature. This is because our parameter doesn't match the variable type. Let's look at syntax number 2. In a way, it behaves the same as syntax 1. However, this time we use curly brackets instead of parentheses and pass in predefined values within. In this example, we have two predefined values and use the add method to pass an additional value. Finally, we are on to syntax 3 for the list collection. Here we define the data type, then use an empty list identifier. And on the assignment side, we use the same syntax, but within the list identifier, we pass a collection limit of integer data type. For example, here we have a list of string with a collection limit of 3 elements. This will create a placeholder within the memory for index 0, 1, and 2, as list starts with 0. For starters, each index will have a null value. Null means empty. We will talk about null value in an upcoming video. However, we can assign values to any index regardless of the order. For instance, we assign John Doe to index 0. Keep in mind we must use this pattern for value assignment when using this syntax. Index 0 now has value and the rest remains empty. Following that, we assign a new value to index 2, which gives us only index 1 that is empty. Finally, we populate a value for index 1. Now that all the indexes are filled, let's try to assign a value to an index that is out of our defined placeholder. We get a list index out of bound error. Let's now discuss set. In contrast to list, set contains an unordered collection of elements. All elements stored in a set are unique. When we talk about set, imagine the following visual: parentheses with values in the middle, separated by comma if there are multiple values. Constructing a set can be done in two ways: using the infinite value syntax or infinite plus predefined value syntax. Syntax number 1 for set looks like this. We define the set collection type, use the angle brackets and place the data type within. Define a variable for it. Then for the assignment, we use the new keyword to create a new instance of the set. Finally, we call the built-in set class along with the data type and the parentheses. For example, here's an empty set of string with the variable name student names. Similar to list, we use the add method to add value by passing it as a parameter. This is what our current visual looks like. Don't forget to visualize it as parentheses and not square brackets. Let's look at an example of an integer set where we already have two values added to the variable. Before we move further, take a good hard look at at our visual. Now let's add a duplicate value. Coming back to the graphic, it appears that there are no duplicate values in our set. This is because set doesn't allow duplicate values. Here's an example of adding an incorrect data type value, which will result in an error. Alright, for syntax number 2, we use the predefined values surrounded by curly brackets. On the screen, we have a variable that has a set of string with 2 predefined values. Additionally, we can use the add method to pass in more data. Final example for predefined values for set is on sObject. Here we have an example of an account being predefined. Note that we must wrap the new sObject initialization with parentheses, as Apex will throw an error. Map. It's a collection of key value pairs where each key must be unique and is case sensitive. There are 2 ways to construct a map: using the syntax of the infinite values or using the infinite plus predefined values syntax. To define a map variable, start by defining the collection type. Then within the angle brackets, pass the key and the value data type. Define the variable name. Finally, as an assignment, create a new instance of a map class followed by parentheses. As an example, we have a variable called student names by number. The variable accepts the key as an integer and the value as a string. To add values to a map variable, we use the put method of the map class and pass in the first parameter as an integer and the second as a string. Here's the visual of the stored map elements. Before we move further, we see that we have James Doe as a student for number 002. Now let's add another student, John James, with the same number 002. For the map, it's a duplicate key. Look at what happens to the visual outcome. John James is now the student with the number 002. This means that a duplicate key overrides its old value. Moving on to syntax 2. Now because a map accepts a key and a value, our predefined values within the curly brackets must follow a specific pattern. First define the key, then use the equal to and the greater than symbol all together. Finally the value. For instance, here we have a map that has a predefined value of a student with his number. We could also add additional students with their numbers using the put method. Next, we have an example on how to have sObject as a predefined values in map. Only thing to keep in mind here is that each new initialization of an sObject must be surrounded by parentheses. Here's the graphic on how it would look. Notice that we have the sObject structure as our map values. Now that we know what the map collection appears like, there are 2 questions to think about. Number 1, what if we want to get all the keys from the map variable? To do so, we use the keySet method that will return a set of whatever the key data type is. It returns a set because the keys are unique. Number 2, what if we want to get all the values? To do so, we use the values method that will return a list of whatever the value data type is. A list is returned because the map values could have duplicates. Let's take a look at an example. Here we have a map with key is equals to integer and a value of string. If we want to get just the keys, we use the keySet method on that variable. This, as we know, will return a set of keys. On the other hand, if we want the values, we use the values method and we get back a list of values. Final topic, collections construction, the extended version. Use the extended collection constructors when we want to construct a new collection based on another collection variable of same data type. For example, if we want to get all the values from existing list to new list, from existing set to new list, from existing list to new set, from existing set to new set, from existing map to a new map, or from existing list to a new map. Let's begin with getting values from existing list to a new list. Define a constructor for list with parentheses and pass the list variable that needs to be copied over as a parameter. Let's say we have an existing list of string that has random names that we want to be copied into a new variable. To do that, we initiate a new list of string and pass the random names list as a parameter. Further down, we could also add more values if necessary. Copying a set to a new list is pretty much the same syntax as before, but this time we pass in a set variable name. To copy list to a new set is critical to understand. The reason being, set is a collection of unique values. Therefore, if the existing list has duplicates, they will get merged into one. Here's the syntax for passing existing list to a set. Define a set and within the parentheses, pass the list variable name. Let's take the example of random names list. Within this list, we have a duplicate value. If we were to visualize this, we would get something as such, where we have John Doe twice. But if we pass the list to a set, those duplicates get stripped down. Set to set is straightforward, as it's the same data type. We just pass the set to a set, no loss of data. Likewise, pasting values from a map to a new map is no different. Just pass the map variable within the parentheses. Last but not the least, passing a list to a map. In this case, the list must be of type sObject. Here's the syntax. Declare a map collection with key as ID and value as the sObject API name, and within the parentheses, pass the subject list that needs to be copied over. For example, let's assume we have a list of accounts that we retrieved from the org using Soko. Then we use that list and pass it as a parameter to the new map collection. This assignment will automatically generate a key value pair where the account IDs become the key and the accounts themselves becomes the values. Before I leave you guys to yourself, I would like you to practice what you learned using the following scenarios. Your job is to determine what collection with its data type can be used and what could be the syntax. This has been Collection Declaration and Basics Part 1. If you found this video helpful, please do like and subscribe. Don't forget to comment your practice answers in the comment section down below, and I will see you in the next one. Until then, be safe and take care. Peace.